Yeah, I have the pleasure to tell you about a little bit about our just finished pilot called EarthLinks, and the full title is Advancing Flexible Linking of Earth Observation Data with Social Indicators. And Kolja just said that this is a also co-funded project between NFDI4Earth and NFDI for Society. And this is, let's say, our social science NFDI. So I'm here today as a social scientist, and I don't know how familiar you are with our work. So for those of you who are not familiar with GESIS, it's the Leibniz Institute for the Social Sciences. And yeah, we are a social science infrastructure institute. And traditionally, we work with surveys. So data collection modes where people are asked questions via questionnaires and we collect their answers. But also for some quite time already, we also georeference these surveys, which means that we use the addresses of the survey respondents and assign geocodes to the locations. And we have several projects still ongoing or recently finished in this regard. The most prominent one for today is GESIS meets Copernicus. It's also about Earth observation data, and I will tell you about it a bit more in a minute. But we also have more bigger infrastructure projects that deal with building general infrastructures for georeferencing and spatial linking, which is the SORA project mentioned here. We also assess data quality of linked data via the CODAX project that's presented here, where we have a specific focus on assessing how good quality of the data is after we linked, for example, social science survey data to geospatial data in the general sense. So some research questions in the social sciences you may not be familiar with are coming from the political geography. I will read them out here because, again, I think you're not familiar with this kind of research. So researchers ask how extreme weather events influence green voting. There are examples from social geography. How does air quality affect patterns of community cohesion? There are applications in economic geography. How do changes in land use affect regional economic development? People in health geography deal with questions, for example, how does the increase in heat waves influence hospital admissions differently across regions? Conflict and peace studies research how do nighttime light level change during post-conflict reconstruction and recovery periods. And finally, as a final example, in energy research, researchers ask how do patterns of wind speed affect the adoption of renewable energy technologies. These are some questions that are asked in the social sciences, but something we have to state in the beginning, or in the very beginning, that's really difficult for ordinary social scientists to actually work with Earth observation data. It's an interdisciplinary effort. Oftentimes it's really explorative research, not only for us as an infrastructure institution, but also for the researchers. So our aim was, since we have started with Earth observation data, to make this research more accessible for social scientists, actually in the first place. But we also like collaboration with Earth system researchers as well. So when we started with GESIS meets Copernicus, so this is the starting period of the Earth observation data, our aim was to have a straightforward interface to Earth observation data for social scientists. And what we did in this project basically was to identify some core variables from the Copernicus data catalog and identify some first applications that we research, but other researchers can also apply in their research as well. The final product was an R package that makes this endeavor hopefully a bit more straightforward. But similar to the project that we just have learned about, also researchers that code like clicky tools. So this is why we started EarthLinks. But first of all, something I wanted to mention. So the basic functionality in our R package is to access Earth observation data, aggregate them to geographies that are entered in this tool, and then link this to the geographies as well. So down here you see the general logic of entering different geographies, such as points, could also be polygons or grids, aggregate them to the level of the Earth observation data, and the output is then basically the linked data. But yeah, if you're interested in this R package and not like clicky tools, here's the link to our R package as well. But again, yeah, many researchers do not like to program their applications, and this is also the case because it's also always people in the social sciences working with R, but other tools are also applied, and they are familiar with more with these. So our aim was to create an even more simple user interface to social sciences for Earth observation data linking. And we opted for an R Shiny app as a technology because it makes it really easy to transfer our R routines to a user interface, a graphical user interface. And I mean, the main advantage of such a tool, I don't have to tell you that, is that users are not required to program. So no programming skills are required. And I mean, yeah, our main audience was the social science community, but it's obviously not limited to them because actually any georeference data can be entered in EarthLinks, and also our package to be linked to Earth observation data. So our basic interface when this R Shiny app is really simple. So we have this big map in front of the screen, and on the left-hand side, we have a menu where we enter different information. So if we zoom in this menu, we'll see some basic information about what EarthLinks is all about, and and I will now go through all the different menu points here. So first thing that's really important to do for users is to upload the input data set. I mean, in our use cases, this most of the time might comprise georeference survey data, but this can, once again, be any georeference data set that comprises points or polygons or even grids as well. And yeah, I mean, we have the opportunity to just upload this data, and then it's also already displayed on the screen on the right-hand side. For our linking efforts, it's really important to have a date variable in this input data set because we want to link these data to current Earth observation indicators at the time of the date. But it's also possible to define baseline periods to have some deviations, for example, from the current date to the baseline period. So this is the example of loading points, but again, we can also load polygons. I mean, this is a really simplified example. This is country-based polygons. Might make not, I mean, maybe it doesn't make too much sense to use whole polygons of huge countries, but I mean, I think you can imagine that you can also use smaller polygons that you can then link to Earth observation data as well. Tool includes different functionalities to ease the use of using the tool, so, such as tooltips and different customizations you could use. For example, a change in the color palettes of the map on the right-hand side, and assigning different labels. But what's I think more important is that is the indicator selection. That is the next point in the menu, where we can select different aggregations levels regarding time. So, for example, daily data, but also monthly data. Also, a button to exclude sea areas, which might make sense for different applications. It always depends on the indicator. And then we can select from different indicators from the Copernicus data store as well. And yeah, after choosing an indicator, we have to enter our API key. This is the ECMWF API key. So users have to be registered to the service before they can use our tool. And then there's a button actually to download the data and link them to the input data. And the result is something, it's just an example on the right-hand side, where you can then compare, and this is really important for us. So for example, answers from a survey questions about climate change concern, and then you can compare the aggregate values of this variable in the survey and the social data with data from the Earth observation data catalog as well. All right, so that's basically it. I mean, there's more under the hood, obviously, especially in the R package. But so far we are, I can say, we are quite happy with EarthLinks. It is an easy interface to Earth observation data for social scientists. So it's really low threshold because people even don't have to register themselves apart from acquiring the API key. And I mean, we just finished the pilot, but we're still in the process of aiming for the publication in our open sciences in C1. So currently the R package, which also includes our Shiny app, lives on GitHub. We hosted the Shiny app also on shinyapps.io. But again, this official publication via CRM, for example, is still pending. And I mean, obviously, this is a pilot, and for us, it's quite explorative. So we really want to open doors for social scientists to Earth observation data. So there's actually more we can do and want to do in the future. So one example is to include more heterogeneous data sources from the Earth observation data. Also, most of it, we solely work with already compiled Earth observation data. So the inclusion of raw satellite imagery, for example, which was something that really, I think, a good extension that I think implies many use cases in the social sciences as well. And something which is still on our agenda, and hopefully this is also an interest for Earth system scientists, is to make our social science data, which can comprise surveys, but also other social data sources, make these data more interesting for them as well and for their applications. So currently we are really working or concentrating on setting up a follow-up project or multiple of them. So this infrastructure we have just built in the pilot, that's, yeah, I mean, it's straightforward, it's easy to install, but it's not a huge infrastructure that is installed on the server somewhere with many resources that can be used. So we really want to expand this infrastructure and yeah, build a tool that is also for the future really prepared and for more computational expensive endeavors as well. So this is also some sort of a call because we're still scouting for partners that are interested in teaming up with the social sciences and bringing in their expertise for some future projects where we can build this infrastructure actually for social sciences, but also for the Earth system sciences as well. All right, so here's the link for the Shiny app that you can use already today. And the link for the R package is also on the slide, and I think the slides will be shared. And yeah, other than that, I'm looking forward to your questions, and thanks for having me and present the project today.